Okay, good. Where is my question paper? Hold on a second. That's not the right option. Where did the file go? Sorry. Oh my goodness. Found it. Yes. Okay. So question 9, we are asking you, given that the coefficient of x power 4 in the expansion of x cubed minus a over x power 8 is -7 over 4, show that a is equal to half. Okay, you got this part. But for part 2, explain why there is no term independent of x in the expansion. Okay, for this one, what you need to do is to get a generic term from the binomial expansion, this part here. And then after that, you multiply that generic term, the TR plus 1, by 8. And then you multiply that TR plus 1 by 2 over x power 4. Okay, then what you realize is that for each of these terms, you'll get x power something. And if you check the powers, you'll just get, you'll never get a constant. What did I mention here? Oh, it can be a constant, but that they will cancel each other off. Do you know what this means?
Oh, so like, wait, so you're saying that if I went to find the term for like x power 0, then there will be like one will be positive, the other will be negative. Then but in the end, it will just equal to 0.
Exactly. Yes.
Okay.
Yes. Yeah, that's it. Yeah, you can go and work it out. What is the two positive and negative terms? Can I work it out for you? Yes, I did. Right. To have constants, we can equate the power to 0, right? After you multiply by the 2 over x power 4 and the constant 8. What you get is r equal to 6 for the first guy and r equals to 5 for the second guy to get your TR plus 1 in each case. Then after you multiply it by the 8 and you multiply it by the 2 over x power 4, you'll end up getting positive 3.5 and negative 3.5. Yes, you can get constant, but they happen to cancel each other off. Yes, then therefore there's no constant. Does it make sense?
Yeah.
Can now? Okay, next question. Also using Wolfram Alpha, just you can type using, you can go and Google that website, Wolfram Alpha. That's an N. You can expand it. They will expand it for you, and then you will realize that they are missing a power 0 term. Okay, if you just look at the powers of the x, it's a 24, 20, 16, 12, minus 12, 8, -8, 4, -4. You sort it in like descending order, and then you realize that there's a pattern, -4, -4, -4, but then suddenly there's a -8 over here. What's going on? It's because there's a 0 that's missing. If the 0 was still there, it would be -4 drop to 0, then -4 drop to -4. And then go to -8 and then -12. Okay?
Okay.
Yeah. Just if you want to check it. This is the actual expansion if you expand everything out. Okay, then next question. What went wrong here? So same thing over in this question. What is this question? In question 10, it's the same thing again, but here they say instead of constant, they talk about 1 over x power 4, which is x power -4. Then what happens is that you again take your TR plus 1, you multiply by the first term 1 over 8x, and then you take your TR plus 1, multiply by the other term x squared over 12. Then you just focus on the power of x. You realize you get 3r minus 9 minus 1 for the first case, and 3r minus 9 plus 2 for the second case. You just have to equate each of them to -4, and you realize that it is possible to have a specific r value that will give you a -4 power. What happens is that it's the same reasoning again. You will get a positive x power -4, I mean a positive coefficient for x power negative 4 and a negative coefficient for the x power negative 4. They happen to be exactly the same magnitude, just different sign, plus and minus, so they will cancel each other off. Okay?
Okay.
Yeah, you can go and check it on your own. I think it's positive 64 and negative 64. Yeah. These two terms will cancel each other off. Okay, then what happened over here? I think it's a typo, just a careless mistake. Should be a over 3, right? Not a over r.
Oh,
Yeah. But then anyways, a over 3 is a fraction, so that means that you can there's no which is not a positive integer, and therefore you cannot have x power 4 term. This is question 11 part 2. I think so. Is it wrong? Let me just double check. Yeah, this one is when you're considering 12 minus 3r equal to 4 and 12 minus 3r equal to 3. Kind of forgot. Why did you equate it to 4 and 3 again?
oh, I have no clue.
Oh, right. Oh, I remember already. Okay. Question 11, part 2. Let's read the question first. With this value of k equals to 2, find the coefficient of x power 4 in the expansion of bracket x square minus k over 2x close bracket power 6, then times 8x plus 1. So you're trying to get the power 4 term, the tr plus 1, you want it to have a power 4, multiply by this constant here to get your x power 4. And then you want the tr plus 1 to have a power 3, x power 3, so you multiply by 8x, then it will become x power 4 again. Yeah, I think that's what you're doing. Correct. Yes. That's what you're doing. Okay. Then I think the mistake over here is just you missed out a negative sign. Negative x power 3. Okay. What else? Here, careless mistake. I think it should be 108. Should be a 108. Because you see over here, to get your, what is it? Let me read the question. Coefficient of x squared, you need to multiply 3 different terms together. Okay, 36a squared times 1, 12x times 9a, 9ax, and then 1 times 42x squared. Okay?
Okay.
If I am not mistaken, let me just double check. Yeah, and yeah, correct. You just have to multiply them all together, and then you get your coefficient of x squared. I think you miscalculated here. Should be 108. Can go and check again. No, 12. Okay. Arrow carried forward. Yes, this one just arrow carried forward. You got the idea. This is correct. And 9a plus. Oh, another transfer error. I think you got tired already. Here is 12, but then you wrote down.
Yeah.
Yeah. So transfer error one time. This one is error carried forward from the previous one. 2 mistakes. Okay, but you got the idea. Yes, equate it to 5, then solve for a. Okay. I will leave it to you. That's the first worksheet. Next one. Yeah, this is question 8 to question 11. The next one will be, is it this one? No, too far already. Is it this one? That's not right. This one. Okay, correct. What happened here? Careless. What was it? I forgot. Here it should be a plus. Yes. It should still be a plus. I can't see. What does it say? 4 minus 7 over 2x. Power 2. It should still be a plus. Whenever you see a minus here, what you should do is to reinterpret it as 4 plus negative 7 over 2x. Or you can rewrite as 7 over 2x power negative 1. Like this. Okay. Then a plus b squared. Or rather, actually, since this is just power 2, you can treat it more simply as whatever you have learned in Emacs. If you recall, a minus b bracket square is what? A square minus 2ab plus b square. Right? it's actually just binomial expansion. Is a plus negative b square, which is 1, 2, 1. Oh, Pascal's triangle, 1, 2, 1. Then you can choose 2 choose 0, 2 choose 1, 2 choose 2, but that's a bit too much. You already know the coefficient 1 to 1. Then you can just put 1 times a power 2 times negative b power 0 plus 2 times a power 1 times negative b power 1 plus 1 times a power 0 times negative b power 2. Okay, it's just binomial expansion, and then you realize you get a squared minus 2ab plus b squared. You already know this. So over here, there's a negative. You should also have a negative. You should still have, yes, you should have a negative here. However, your b here is no longer a negative 7 over 2x. It's just 7 over 2x. Don't need the minus here. Do you get what I'm saying?
I think so.
Yeah, so basically, this is a, and there's your b. So your b is just this part here. If you want to use this formula, a squared minus 2ab plus b squared, the b doesn't include the minus. The b is just this purple part, 7 over 2x power negative 1. I just color code it for you. Okay, yeah, so there's it's off by a negative sign. Here should be a minus, not plus. Then just arrow carry forward. You can calculate it. I believe it's 8,206. Then over here, you got 168. Also careless mistake, should be 336. I think, I suspect, okay, I'm not too sure actually. Maybe not that accurate. Maybe you type in 7 permute 2, is it? Type in 7 permute 2.
No, because it
it's
equals to 42.
Oh yeah, yeah, should be even worse. Okay, I'm not sure what you did. Yeah. Anyways,
I just
okay, I'm not sure what's the careless mistake you made, but it should be 336.
Yeah, I redid it, then I got 336. I also don't know how I got 168.
I also don't know. Okay, just use a calculator. Don't worry about it. Yeah. Nothing much. Yeah, just use a calculator. Then next one, question 15. Careless mistake over here. Px cubed power 5 should be p power 5. Then x cubed. So you have to multiply by 5. So power 15. Oops. Like this.
Oh my God.
Right? Then you're off by a power. 3 should be a 5. So error carried forward, blah blah blah, but you know how to solve. Okay, so I will not talk much about it.
I have like 9,000 careless mistakes.
Yeah, it's because I don't know. You just have to be alert. 29 is fine. 17 is fine. Here you just need to know p plus qx squared is the same as qx squared plus 0x plus p. There's a hidden plus 0x. Okay, so the coefficient of x is 0. Then you can just compare. 4a minus 12 is equal to
0.
Yeah, then you can solve for
Solve for A.
then the rest you know how to do it. Yes, that's all. Okay. This one 18 done. 18b. This one, okay, I'll go through. Let's see. 18b is, it is given that in the expansion of 5 plus px bracket power n, the coefficients of x cubed and x power 4 are the same. Express n in terms of p. Okay, so coefficients are the same, so you know the procedure, but after you reach this step, you got stuck, right? So yeah. I gave you a hint. Use this formula. Okay, now I'll go through the hint. Let me just copy down your working because it's very good. Don't need to react. I'm just gonna copy it and paste it here. Okay, then I'll do my work, continue my working below. So what did they tell us? Coefficient of x cubed and x power 4 are the same, so we should rewrite it such that this first fella, we can extract its coefficient. So if I rewrite it, it will be n choose 3 times 5 power n minus 3 times p power 3 times x power 3. The other guy will be n choose 4 times 5 power n minus 4 times p power 4 times x power 4. Okay, so now we can see the coefficients very clearly already. This part here and that part there. Then you just have to equate them. So since their coefficients are the same. Okay, maybe I should write a short statement. Since coefficient of x cubed and x4 are the same, this equals to that. Purple equals to green. Okay, then now how? How do you express n in terms of p?
Wait, how is the formula? It's like this, or
There are two forms of the formula. Let me write it down for you. N choose R, also equivalently N choose R. If you are in China, they write it like this, N here, R there. I don't know why. It will be N times N minus 1 times dot, dot, dot until N minus R plus 1. Count down, basically. Count down, and then you need how many factors? R factors. Okay, then divide by R factorial. Alternative formula would be N factorial over R factorial times N minus R bracket factorial.
okay.
I would prefer using this formula because it's easier.
Oh, okay.
I'll show you. Okay, let me get rid
Yeah.
of the highlight now so it's easier to see. Okay, how do you deal with this? Remember the goal is to make n in terms of p. So n choose 3 is really just what? N times n minus 1 times n minus 2, and then I stop. Why? I see 3 here, so 1, 2, 3 factors. Then I stop. You can check this is n minus r plus 1. Correct?
Okay.
N minus 3 plus 1. Yeah. Okay, then you divide by 3 factorial.
3 factorial.
Now, let me ask you a question. N minus 3, n minus 4, which is smaller?
N minus 4.
N minus 4. So I'm going to rewrite 5 power n minus 3 as 5 power 1 times 5 power n minus 3. Sorry. Small. N minus 4, sorry. Is this correct? Same base, different power at the power, right? Okay, good. Your indices still remember. That's the next topic I'll be going through already. Okay, then the left-hand side. Okay, I don't want this. I want to expand it. So n choose 4. Can you write it out for me? You want to try? What would it be? I'll read it out. N times n minus 1.
N times n minus 1 times n minus 2 times n minus 3 over 4 factorial.
Very good, yes. And then multiply by 5 power n minus 4. Oh, by the way, I put a dot here to mean multiply. Then p power 4. This is a common symbol that will be used in university and onwards. Okay, good. So how do you simplify this? What you should realize straight away is 5 power n minus 4. Cancel. Okay, let's just do it step by step. Okay, copy and paste, and then remove the one we cancelled. Anything else to cancel?
The p to the power 3.
So this one left with a single p. Just to be neat, I'm going to rewrite it again. So I have an iPad, so I can do it quite fast. If you want, you can just
Yeah, I don't know how you do that.
Duplicate. I am using Notability.
I also have Notability, but I don't even know how you.
Use wait. Screen. You're seeing my screen, right? You can see my movement. Yeah. Circle it, click it, and then you select duplicate.
Okay.
Yeah. Okay. Okay. Can. So now this one, you get simplified form already. 5 power 1. Of course, you don't need to write the power 1. Oh, I'm just writing it for emphasis. Like to remind you 1 plus n minus 4 gives you n minus 3. Always pick the smaller guy. Okay, then anything else to cancel? Can. You see n here? Divide by n on both sides. They will cancel off. N minus 1 also cancel off. N minus 2 also cancel off. 3 factorial, I'm gonna rewrite as 3 times 2 times 1. 4 factorial, 4 times 3 times 2 times 1. Anything else to cancel? How about if I multiply by 3 times 2 times 1? Then I have to do it on the right-hand side as well. Anything to cancel now?
Yeah.
Yes, exactly. Good. So cancel. Maybe I'll use a different color. 3, 3, 2, 2, 1, 1. 3, 3, 2, 2, 1, 1. So satisfying. Everything cancels off. What are you left with?
5 equals to n minus 3 times p.
Anything else?
Isn't there like bracket? No. Yeah.
Anything else?
divide by 4.
Yes. Okay, perfect. Okay. Then you can, what was the question again? Express n in terms of p. Okay, so make n the subject. Then I'll just times 4 over 20 n minus 3 bracket times p. Divide by p. So n equals to 3 plus 20 over p. Done. Can?
Okay.
Yeah. So the trick here is make sure you know your factor or your definition of n choose something, n choose r. Use this formula. Easier. If you use the factorial one, you're gonna make your life worse because there are even more factors you need to cancel off. You have to write even more. Oh, yeah. I think it's the easiest way already. Just manually expand everything out. Then you can very obviously see cancel all the factors one by one. Okay. Okay, good. Let's move on. This is my part B. Anything else? Yeah, that's it for this worksheet. Please remind me to send you the files. I will forget. Or
Wait,
if you
what
copy
do you
down.
mean by file?
I wrote down the annotation, right? Yeah. Like this.
Or like, huh?
The
Yeah.
working. Oh no, I just wrote down something new. Then later I need to
okay.
send you again. Yeah. Please remind me if I forget.
Okay.
Yeah. Next one is 19. Nothing wrong. This one. The numbers you notice here are quite big.
Yeah.
Modern calculator can do this. But in the past, people, like I remember I had an old teacher, 50 plus. He studied, I don't know how old is he. I think he already retired. He was the generation that did secondary school math, all this content without a calculator. They had something called a slide rule, and logbooks, logarithm table. If you heard of it.
Okay.
Okay, I'm gonna send you a video. Send video. This one is related to logarithms. You will learn it in the future, soon. But we are not using slide rule anymore. We are going to use a scientific calculator. I don't know how to use slide rule also. Yeah, then this kind of manual calculation is a bit too difficult for them in the past, so there is actually a better way. So 18 choose 6, 18 choose 7. You're gonna take a ratio. What do you think will happen when you divide? What will happen if you try to expand this manually without a calculator? You get all the factors. Then I think you should realize that a lot of them are the same, right? As what I have written down over here. A lot of them are the same. Do you know how to simplify this? This one go here, this one go there. Oh, okay, I show you a simpler case. Let's say you got 2 over 3 divided by 5 over 7. Do you agree that it is 2 times 7 over 5 times 3?
I mean, now that you tell me that, I'm like, sure. Yeah.
Yes, right? Okay, how do you check that it is correct? This is called dealing with nested fractions. If you watch Khan Academy, they got talk about this. Basically, you take this fraction on top and this fraction below. This is what we call nested fraction inside a fraction. How you deal with it is you multiply top and bottom by the same number. In this case, I'm going to choose 3 times 7, 3 times 7. Why? Because now I can focus on the numerator, 2 over 3 times 3 over 7. What happens? 3 cancel. Look at the bottom, focus on the bottom. 5 over 7 times 3 times 7.
7 cancel.
Yes, exactly. Then therefore you're left with, let me get a highlighter, 2, 7 at the top, 5, 3 at the bottom, which is what I've written over here. Is it clearer now?
Yeah.
Can yeah, then it's the same thing, just that with a lot more factors. I think you can see this is like the fraction on top of another fraction. So this one goes on top, that one goes below. I color coded it so you can go and take a look. And almost all the factors cancel off except for 7 over 12. Can all right. Yeah. Okay. So 7 over 12. Let's move on. So this is question what? Question 19. So in question 19, we got coefficient of x power 6 and coefficient of x power 7. So simplify into this form. Then you can just divide them and you get 7 over 54. Right? So what happens next? Got fraction over a fraction again. Bottom goes on top, bottom goes below. Then you simplify it to this form. Is this okay?
Yep.
Okay, then what happens when you got 2 power 12 divided by 2 power 11?
Cancel.
Cancel off, you're just left with a single 2, right? So that's a single 2. How about k power 14 and k power 12? Cancel.
Cancel.
Left with how many copy? 2 copies on the top, k squared. And 18 choose 6 over 18 choose 7. It's just a different way of writing 18 6 divided by 18 7. I already did the working on top. It's 7 over 12. Remember? This. Then I just substitute with 7 over 12. Okay, good. So now we finally simplified it into this format. A lot simpler. Don't even need a calculator anymore. So yeah, just solve it and you eventually get k squared equals 1 over 9. Take the square root, you get plus minus 1 over 3. But you have to, oh wait, this one cannot reject. You cannot reject. Both are acceptable. Can?
Okay.
Okay, let me just change the mode back to presentation mode. Bigger screen. Okay. Next one, question 21. Oh, here. These two do not cancel off. You see 80 over 9 and minus 80p over 3. They don't cancel off. Wait, and there's a 32x squared. These 3 terms must combine together. You only wrote down a single 32, so it's not correct. Can I leave that to you to do the correction?
For question 21.
Yeah, question 21. You only wrote down a single 32. You just forgot to include the other 2. Can try the correction, then send to me. I'll mark it again.
Okay.
I don't go through. I think save your time. Next, 22 is perfect. Okay, good.
Yeah,
you know how to expand. Yes.
I think you missed out on question 20.
Oh, is it? Sorry. What's question 20? Oh, what's question 20? Sorry. Let me check. Oh, I really missed out on question 20. Sorry. Let me read the question first. Write down in ascending powers of x the first 3 terms in the expansion of 1 minus x over 5 power 6 and simplify the coefficients. Okay, let's mark it now. Sorry. This is negative. So that the power 1. Yeah, this is correct. Okay, and then 6 choose 2 times negative 5. Okay, this is correct. Then you get, what is 6 choose 2? 6 times 5 over 4. Never mind, just use calculator. 6 choose 2 is 15. Multiply by a bracket negative 1 over 5 bracket square. Get 3 over 5. Correct, good. What's part 2? The first 3 non-zero terms in the expansion of 5 plus bx multiplied by 1 minus x over 5 bracket power 6 are a minus x plus cx squared. State the value of a. All right, so a is the constant term. That means we want to expand until we get the constant term. So I see constant here, I see constant here. That's the only way. So 5 times 1, which is 5. So a is equal to 5. Correct. Good. Next, we want to find the value of b and c for part 3. Let's see what you did. Okay, you just expand everything. Can 5 multiplied by 1 negative 6 over 5x and 3 over 5x squared. You'll get 5 minus 6x plus 3x squared. That's correct. Then bx you multiply. So bx times 1 is bx. Bx times negative 6 over 5 is negative 6 over 5bx squared. And then bx times 3 over 5x squared, you get x cubed term, not relevant to the question anymore because they only give you up to cx squared. So you don't expand and you put plus dot dot dot. Okay, that's fine. Here you also should already put the plus dot dot dot. Right, because there's actually more terms. Okay, and then you write down. What did you write down? Oh, you combine them. Okay. Let's see. So 3x squared minus 6b over 36. What is this? 3 and I am a little bit confused. What is this?
I don't know. I don't even know.
Okay, this should just be bracket 3 minus 6b over 5 bracket x squared. Yeah, then that's the coefficient already of x squared. Okay, let's see. That's not very good because we are gonna equate it to 6. But never mind, your b minus 6, the coefficient of x is okay. It's correct. then yeah, we can just equate this to -1, which is what you did over here. Yeah, because this is equal to a minus x plus cx squared. Let me increase the font size a bit. Yeah, so b minus 6 is equal to -1. So bring the 6 over, you get 5. Correct. Your 5 is correct. Sub b gonna find into this. Okay, I'm not sure what's going on, but it should be 3 minus 6 times b, which is 5 over 5. And then you equate it to c.
Yeah. Okay.
3 minus 6, -3. Okay. Yeah, so this is just a careless mistake. This is wrong. I don't know why is this 3 6b over 5 wrong.
Yeah,
Okay.
I also don't know.
Okay, so yeah, c equals -3. Next question. Let's see. Question 21. Okay, I'll leave that to you. Question 22 is good. Here I just draw for you a table to expand everything up. The trick here is I just write down all the terms, okay, in a row and then in a column. Then I consider all the ways. Tic-tac-toe. But I don't care about the coefficient. I just look at the power. 1 with 1, 1 plus 1. 1 with -1, then 1 plus -1. 1 with -2, 1 plus -2, so on and so forth. You get what I'm doing, right?
Yeah.
Okay, I'll just add the power. Then what I do is I list down all the possible powers of each expansion already. 2, 0, -1, 3, 1, 0, 4, 2, 1. Then I start to answer the question. Okay. But good that you are able to see it immediately. Yeah, so I won't talk much about it. Yeah, you can see the terms and your answer is all correct. So I got nothing to say. Can?
Okay.
Okay, then you missed out on question 23.
Yeah, I don't know how.
Okay, let's just do it. Question 23. Here, let's go. Expansion of a plus x multiplied by 1 minus 4x power n is in ascending powers of x is, I already exceeded 30 minutes. Sorry. Okay, it will be this guy, where a and b are constants, n is a positive integer. N is positive and n is integer. So it's a natural number. And n, yeah, find the values of a, b, and n. Okay, then very simple. Since they only expand up to x squared, we will expand the 1 minus 4x up to x squared as well. Since we see that there's a constant here and a linear. Expand until x cubed is not relevant. So expand in ascending powers of x, right? So we are also going to do that for this power n one. It will become n choose 0 times 1 power n times -4x. Oh, by the way, sorry, I forgot to mention, you must rewrite it like this. A is your 1, B is -4x. Yeah, then just use the formula only. Power 0 plus n choose 1 times 1 power n minus 1 times -4x power 1. Can you tell me, can you try the last third term, the x squared term? Plus what?
N2
Times 1 power n minus 2. Of course, it's just a 1. Then the next one?
Then, yeah, -4x to the power of 2.
Yes, correct. And plus dot dot dot. Simplify. N choose 0 is just a 1. Maybe I'll just cancel on top like this. This is 1. 1 power n is 1. n power 0 is still a 1. Oh, maybe I shouldn't cancel. Very messy. I'm just going to copy and paste it first and then I cancel. I can do that because I have an iPad. Cancel, you get a 1, a 1, a 1, 1 times 1 times 1, which simplifies into a 1. Plus, n choose 1 is just a n. 1 power anything is just a 1. N times 1 is just an n. So I get n multiplied by -4x. Simplify it straight away, I get -4nx. Is this part okay?
Yeah.
Okay, next one. N choose 2 is what? What's n choose 2?
N and then times n minus 1. Then over 2.
Yeah, 2 factorial, which is 2 times 1, which is 2. Then 1 power anything is 1.
1
times 1. Don't need to times 1, sorry. It's obvious. Then -4x squared.
16x squared.
Yes. Then the 16 and 2 cancel off. 2 becomes a 1, 16 becomes a 8. Okay, clean up. Just to be neat. Copy and paste it again. Then I replace this with just 8. So it's just 8 times n minus 1 times x squared. Okay. Are we done? Can we equate it to the half minus 15x plus bx squared?
Yeah.
Are you sure?
Never times the a plus x yet.
Yes, that's the missing. So the answer is a no. You must multiply by a plus x first. Okay, so that's what we're going to do. So this is equal to a plus x multiplied by whatever we found. I'm going to rewrite this. 1 minus 4nx plus 8n n minus 1x squared plus dot dot dot. Multiply out constant a times 1 plus linear term will be x times 1, a times minus 4nx. So plus x bracket 1 minus 4an. Then quadratic term. X times x will give me x squared. So I'll have a negative 4n times 1. Then a times 8n n minus 1x squared will give me my other quadratic term. So 8a n minus 1 plus dot dot dot. Okay, but we also know that this is equal to half minus 15x plus bx squared. This was given. Then we can just compare coefficients. Constant, constant. Conclusion, a equals to half. Linear, linear. So we get 1 minus 4an equals minus 15. But what's a?
Half.
So times half times n equals negative 15. Simplify. 4 times half is 2. 1 minus 2n minus 15. Solve for n. Let's see. Plus 15. 16. N equals to 8. Sub a equal to half. Are we done? A and n? Are we done with a and n? Just a and n?
Yeah.
Wrong. Read the question. Part 1, they ask for b as well. So last one, b coefficient of x squared. Okay. So b equals to negative 4n, which is 8, plus 8 times a, which is a half. Ayo, no space. Wait. Okay, b equals to negative 4 times 8 plus 8 times a, which is half, times another n, which is 8, times n minus 1, which is 7. Then just key inside your calculator. Minus 4 times 8 plus 8 times half times 8 times 7. 192. Okay. Is it okay? Mic test, can hear? Can I move on?
Yeah.
Okay, can. Oh, I think your mouth move away from the mic. I cannot hear. Yeah. Okay, I can move on. Then I move on. Part 2. Find the coefficient of x cubed in the expansion of this fella. Okay, so wow, why did they do that? Coefficient of x cubed. That means that we are not done. This x squared not enough. You still need to expand until you get an x cubed, so you can multiply by the a. All right.
Okay.
Yeah. So we go back to our original expansion. We are not done yet. This fella here, 1 minus 4x power n. Yeah, new page. You have to continue with n cube, the x cube. Sorry. So n choose 3 power. Okay, multiply by 1 power n minus 3 times negative 4x power 3, then plus dot dot dot. Of course, the first few terms we already know what is it. It is just 1 minus 4nx plus 8n times n minus 1 times x squared. And I am simply wait a minute. Actually, we know the value of n, right?
Yeah.
What's n? N is 8. So actually, we don't have to deal with the generic variable version already. But never mind. I'll just use it since I already write halfway. Then n choose 3 will be n times n minus 1 times n minus 2 divided by 3 factorial times 1 power whatever is still 1, so ignore it. Negative 4 power 3 is negative 64 x cubed. Take note that negative 1 power 3 odd power will give you a negative, even will give you positive, so it's still a negative. Let's just simplify this a bit. Simplify, I don't know, becomes a negative, right? So I'll put a minus sign here. 64 over 3 factorial, which is 64 divided by 6 is 32 over 3. So I'm just going to write down 32 in front and 3 below. Is that okay?
Yeah.
Plus dot dot dot. Plus dot dot dot. Okay, then since n is equal to 8, since n equals to 8, if it's power 8, I'm sure you know how to expand it. Just do it step by step. But we can also substitute in the n with 8. So 8 times 4 will be 32. So minus 32x plus 8 times n, which is 8, times n minus 1, which is 7. 448 x squared minus 32 times n is 8 times times 7 times 6 over 3. I think I got a 3584. Yes?
Yeah.
Can yeah, so that is still not done yet, because we are trying to find the x cubed in expansion of not this 1 minus 4x power 8, but rather a plus x. Okay, I'm just going to replace the a straight away with a number already. What is a?
Half.
Oh, half. Yes, correct. I forgot. Okay. Half times 1 minus 4x power 8. So we get half plus x multiplied by copy and paste. Wait a minute. What is it they want? Coefficient of x cubed. Sorry. Yeah, so you just need to take this times this and this times this. Yep. So how do you spell COEFF? Coefficient of x cubed will be equals to yes. Okay. Let me double check if it's correct. 448 times 1 and then negative 3584 times half. Yeah, correct. Yes, you wrote down already. Okay. I'll just leave it. You write down already, then that's all. The alternative solution to this would be after you figure out what is your what do you call it? You figure out that n is 8 already and a is half. So you just got this equation. What you can do is you can find out the TR plus 1, where you have a x squared and an x cubed. Right?
Oh, okay.
And find the correct R value, then you multiply x cubed by a half to get your cubic, x squared by the x to get your cubic again. Yeah. I think you know how to do that. I don't go through. I think this is manual expansion is faster, actually. Only 4 terms are quite fast. Okay, that's can we have a short 3-minute break? I need to use the toilet.
Okay.
Yeah, then when I resume, I'm going to talk about a new topic, indices, surds, and logarithms and exponents. Okay, bye-bye. Come back in 3 minutes. Mic test.
Yeah.
Okay, let's go. So, I think you have the worksheet already, right? I sent on Telegram. So, just my plan is to go through everything.
Okay.
Yeah. We'll see how fast we can go. The rest that I cannot complete in lesson will be. No, I'm not gonna go through all in one lesson. Okay. 1.1, 1.2 will be today. 2 will be next lesson. 3 will be other lesson. Okay.
Okay.
We'll see how fast we can go. Okay, so let's go through. So this is recap on indices. You should already know all this from Emacs, but it's just a recap. I'll choose some of the questions to do. Okay. I'll choose some of the questions to do. Let me just start a new page. Wait a minute. Paste it here. Okay, so this is question 1. Let's go. So you have 2/3 power x equals to 5 and 2/3 y equals to 7. Can you solve for x? Not really, because typically you would have, for example, like if this was the equation, you can rewrite it as 2/3 square, right? Then you can conclude x equal to 2. Yes?
Yeah.
If this was the original equation. But now we got 2/3 power x equals to 5. You cannot solve. But actually you can. There is a technique known as logarithms that helps you to solve it. It's actually a definition, but yeah. Now you can just ignore it. It will actually just be ln of 5 over ln of 2/3. Do you know where's the ln button?
LN.
Below
Like
the
on
on
the-
button.
Uh-huh.
ln.
Yeah.
And type this in. What do you get? Make sure you close the bracket. Never close bracket, cannot continue. Must close.
Minus 96936296.
So that is currently in your ANS. So what you want, can you just type in for me 2/3 to the power of ANS? You should get back a 5. Yes?
Yeah.
Yes, okay, good. Then that's the power. So whatever, you are not expected to solve it by hand. Nobody can do it. I guess no, most people can't. I cannot. You have to use a calculator for this, or a slide rule or something. So this is logarithms. We are not dealing with logarithms yet. This question is indices. You can use some tricks to help you to get around to finding out the answer to part A, B, and C without you finding out the value of x or y. Okay, you already this is the value of x, -3.969. But that's not the purpose of this question. They want you to be a little bit trickier. So over here we got 2/3 power x equals to 5. We also got 2/3 power y is equals to 7. Without the use of a calculator, find the value of 4/9 to the power of half x. How? First thing you should realize is 4 is 2 square, 9 is 3 square. So it's 2/3 bracket power
X
square, then times half x, which is just a x. Yes.
5.
Which is 5. Correct. Part 2, 3/2 power 2x. Do you realize that it's related to 2/3?
Yeah.
But it's to the power of
Minus 2
minus 2x. Yes. Yeah, -1 and then multiply by 2x. But then, do you know that you can always swap the order of multiplication? So that means that 2/3, you can raise it to the power of x first and then power -2.
Okay.
Agree? Yes, right?
Yeah.
X times -2 gives you -2x. But what's 2/3
5.
power x? 5. So it's 5 power -2, which is 1/5 power 2, which is
1/25.
Very good. Then part 3, let's go. Part 3 is 8/27. Anything familiar about 8 and 27?
This one cube.
What cube?
2/3.
Correct. 2/3 cube. Slowly, it's cubed first, then to the power of x plus y. Plus y, x plus y, not just y on its own, not just x on its own, it's x plus y. Do you agree with me that it is really just 2 over 3 power 3 times x times 2 over 3 power 3, oops, missed out a bracket, power y? Correct or not? Same base, different power, you multiply, you just plus the power. Is this okay with you?
Yeah.
Can Okay, then therefore this 2 over 3, oops, 2 over 3 power 3, then power x can be swapped around. So it's power x first, then power 3. Same thing with the other guy. Power y first, then power 3. So yeah, you know.
To the power of 3 times what is it, 7 to the power 3.
Yes,
okay.
very good. Yep, exactly. So let me just type it in the calculator. 42875. Yeah, correct. Okay, so yeah, you don't need what is the main point here? You don't need to solve for x and y. Yes, that's the main point of this discussion. Question 1. Let's try another question. This one. Okay, interesting. Maybe I should go from top to bottom. Do you need me to recap with you this kind of question? Emacs. Up to you.
I mean, I don't know.
Okay, we go through one. Okay, basically convert into positive index. I'm sure you did a lot of these type of questions already from Emacs. It's the same thing, just a recap. Okay, question 2, let's go. So for part A, never mind, I'll just go through as I go along. The rules. Do you want me to give you all the rules? List down all the rules? Or you already know, we just go straight to question. Like a power m times a power n equals a power m plus n. Do you want me to go through them?
I think I know.
Okay, I trust that you know, because I also want to save your time. We'll go through and I'll see how you respond. Yes, so power 0 is what?
1.
1, very good. Then here, I just copy down first. Step by step. Okay, then power -2, what happens? When you got negative power, you flip. Okay, good. So that means we'll flip the fraction. 2a power -2b power half goes on top, 1 goes below. Divide by 1, might as well not write it. Then to the power of +2, because the negative went in already. Okay, then square. There's 3 factors here. There's a power 2. Yes. -4. Half times 2, 1. Power 1 means don't need to write the power.
Yeah.
Okay, then you want positive index, right? So 4b on b stays at the top, then a power -4 go below, change the sign from minus to plus. Answer. Can?
Yeah.
Okay, good. Part B, this one just recap. I'm sure you know all this. Okay, then a plus b to the power of -12 times a power -1b power 2 power 3, all divided by cube root of a plus b, bracket. Then outside of this cube root, you have a power 6, multiplied by square root of a power -2 times b power 4. Then outside this entire square root, there's a cube. A bit challenging because there are square roots involved.
Okay. I mean, okay.
Tell me what to write, then I can write out. I think it's faster.
Okay.
Yes, correct. Let's go even faster. Power 6, and then you got power 1/3.
Yeah.
What happens?
2 power 2.
60832. So it's just a plus b power.
A plus B power 2.
Very good. Then on top we got a plus b power minus 12.
Minus 12.
So can you bring it down?
Yeah.
What happens? It becomes positive 12. Same base
14.
a plus b, right?
14.
So plus 12. Yeah, so plus 12. 14, yes. I'll write it later. I'll just write down plus 12 for now. Show some working in case you forget. Then this one and this one.
This is this.
Yes.
Then if you times throughout, then you become a minus 1.
1 b power.
Then b
2.
power 2. Then power 3.
Yep.
Then this one can cancel. Right?
Yes, exactly. Then you're left with nothing. Okay, then that's it. Done already. Easy, right? Okay. You know what? I'll be lazy. I'll just write a 14. Can watch the video recording if you forget why it's 14. Answer. Okay. Okay, good. Yeah, you know all this. I think I'm gonna skip since you can solve this kind of question. Maybe. Oh, that's not easy. Whoa, bad. Let's just skip that question. Oh, you can try. This is very difficult. Question 3B. Stop. You can try. Okay, let's go to the next question. Question 4. Okay. Let's go. So question 4, using the substitution p equal to whole power x, solve this equation.
Okay.
Tell me what to write. Then I write for you. Oh, you want to write?
Oh, I mean, okay, this one can just be 2p. No. Wait, sorry. Wait, what am I saying? Oh yeah, no, wait. Yeah. Okay, yeah.
Right? Yes?
Yeah.
What's 2
p
power x?
square. 2p square.
Yes, very good. Okay, 2p
minus
square.
5p minus 12.
Exactly. Then just solve for p. Use calculator. 2 minus 5 minus 12. I get p minus 4. 2p plus 3. Okay? Then p is equal to 4 or p equals to negative 3 over 2. So now do you think we are trying to solve for p or trying to solve for x?
Try to solve for x.
Yeah, so don't stop there. You solve for x, back in 2 power x equal 4. 2 power x equal negative 3 over 2. 4 is 2 square. Yes, good. Then therefore x is equal to 2. Okay? Can change the handwriting. Okay, that is the left side. But here, 2 power x equal negative 3 over 2. Do you have a solution? No solution. Do you remember why?
Why? Because negative.
Yes. How does an exponential graph look? It looks like this.
Yeah.
Oh, then negative 3 over 2 is here. Then the solution is when the point of intersection. Sorry, you will have a solution if the two graphs are of the left hand side and the right hand side, they have an intersection. Here there is no intersection, so no solution. Okay, it's what we call an asymptote here, where at y equals to 0. The y equals 2 power x graph for very small values of x will never touch the x-axis. It will be always slightly above the x-axis, slightly positive, but never touching it. The value of 2 power x for very small values of x will be a very small positive number. Okay? Can understand now?
Yeah.
Can. Okay, good. That is indices. You need to know substitution. What else? Yeah, all these are quite easy, I would say. Oh, no. Okay. Let's just do another substitution question. Question 7. Let's go. Okay, let's go. So using the substitution y equal 3 power x or otherwise solve the following equation. This one is 2x times 3 power. What's 3 power 3? Is it 6? Is it 9?
27.
Yes, it's 27.
27 and then p square minus 28. I mean not p, I mean y.
Oh, yeah, sorry, I didn't catch that also. Okay, y squared minus 28y plus 1 equals 0. Yes. The equal sign is over here. Don't put the equal over there. Okay. Can yeah, so now we want to solve for y. How? Just use a calculator. Exam strategy, just yeah. Y minus 1, 27y minus 1 equals 0. Okay, so therefore y equals to 1 or y equals to 1 over 27. Y equals to 1 means 3 power x equals to 1. Remember, we are trying to solve for x. Yes, correct. This is 3 power 0, so x equals 0. Then therefore, this other one, 3 power x equals 1 over 27. How? How is
20 isn't minus 3. So yeah, x equals negative 3.
Exactly. Good. Okay, easy. Can next. Or anything else that's actually difficult for you? Okay, simplify this one. This one have addition. Question 8, question 8. Oh, yes. Should try question 8 and 9. 10 as well. Maybe 11. Okay, just go through. Let's go. Paste here. Crop. Let's take a look at question 8. Given the following, cube root of 14 power h over square root of 2 power 2 minus k equals to 28, where h and k are integers. Find the values of h and k. Can I just go through this question entirely?
Sure.
Can I? Okay, the key thing here is you need to prime factorize the 28. It's 4 times 7, right? So it's 2 squared times 7. Agree?
Okay.
Yes, okay.
Yeah.
Now we're gonna leave that alone. We're gonna purposely swap it around like this. So what I'm gonna do is I'll write the 2 squared times 7, which is 28, on the left-hand side. But on the right-hand side, I copy down this expression. Then I try to simplify the right-hand side without without having to copy down the 2 squared times 7 many times. Okay, so let's work it out. How can you relate 14 and 2 here to 2 and 7? 14 here is
2 times 7.
Very good. So that's why we can split it up as cube root of 2 times 7 power h. So 2 power h, 7 power h. Divide by square root of 2 power 2 minus k. Then we can split it up now into 2 power h over 3 because cube root is 1/3 power.
Yep.
7 power h over 3. The denominator will be 2 power 2 minus k over what? 2, right? Square. Can? Good. So now we can see that there's 2 power something over 2 power something. You're dividing same base, different power. So you have to subtract the power. But be careful, you have to minus the guy at the bottom. So 2 power h over 3 minus 2 minus k over 2 multiplied by our 7 power h over 3. Is this okay so far? Okay, then now you realize that left-hand side is 2 squared times 7 power 1. 2 power something, 2 power something. 7 power something, 7 power something. You can now compare. Because this is a prime factorized version of a number, it will be unique. You will prove this in university, year 1, semester 1, that the prime factorization of a number is unique. So confirm there is no other way, you can just compare the powers. For now, you just need to know you can compare the power like this. That's all you need to know. Okay? And 1 equals h over 3. Which one do you think we want to solve first? The complicated one on the left or the easy one on the right?
Easy one on the right.
Of
and
course.
Then sub h.
Very good. So h equal to 3, then sub h. Okay, this one I already sub in now. Right, h with 3. Then 2 equals to 1 minus 2 minus k over 2. Minus 1 on both sides, you get 1 equals to negative 2 minus k over 2. Multiply by negative 2 on both sides, you get negative 2 equals 2 minus k. Right, this negative 2 bring over.
K equal 4.
Yeah, k equal to 4. Yes. Okay, so here the only thing that is difficult is you need to know the comparing trick. Okay, the comparing trick. 2 power something, 7 power something. Compare. Okay, the rest is easy. Next question. Let's go. Once you know the trick, it becomes very easy already. Okay, next one. This one, wow, a little bit challenging. Notice that okay, not notice. You haven't. Okay, recall that the exponent rules they are mostly dealing with multiplication and division, right? Like for example, 3 power m times 3 power n is 3 power m plus n. The addition only happens in the power. Agree?
Okay.
But here, take a look. There's addition going on at the denominator between two exponentials. So that is quite difficult because we don't have any rules to deal with it. The only rule that we have is factorization. Okay, so what do I mean? Remember just now about just now when we are doing binomial expansion, there was a 5 power n minus 4. I asked you versus a 5 power n minus 3. I asked you which one is smaller. Which one is smaller?
N minus 4.
N minus 4 is smaller. So I always choose to deal with the bigger guy. I rewrite it as 5 times 5 power n minus 4. So I force it to have the same factor. Can you see the trick?
So
we're going to do that same trick here. 3, let's copy down the question first. Wait. So which is the biggest guy?
N plus 5.
N plus 5 is the biggest guy. So that's what we are going to deal with. We're going to deal with the biggest guy. We're going to rewrite this biggest guy as, okay, actually, sorry, leave the numerator alone. Focus on the denominator.
Okay, n plus 3.
N plus 3 is the bigger among the bottom guys. So we're going to work with the 3 power n plus 3. We're going to rewrite it as 3 power 2 times 3 power n plus 1. Is that true? Can, right? Okay. I didn't do wrongly. Okay, good. Then here you have to times 1, invisible 1. Then notice that you can factor out something at the denominator. What is it? Common factor is?
N plus 1.
Good. Then you get 1 plus 3 squared over n 3n plus 5 on top. Can?
Okay.
Then anything to cancel? It's a factor now, so you can safely cancel. Sorry? You were saying? Cancel off what? Okay, I'll just continue. Then 3 power n plus 1 and 3 power n plus 5, you just cancel off n plus 1 copies. N plus 5 take away n plus 1 is 4.
Okay.
Yeah, exactly. 3 power 4 is 81. Then 1 plus 3 squared is 1 plus 9, which is 10. Then that's your answer. Can?
Okay.
Okay. So the trick here is just like binomial expansion just now when we are doing like n choose 8 over n choose 7. Same trick. Same trick. Okay. Make sure you got factors that can cancel off top and bottom. Okay. Question 9 done. Let's go to the next one. Is this relevant? Yeah, never mind. I'll leave this to you. You can do as homework. This one I'll go through. Let's see. Question 11. The rest are all quite easier. Not gonna bore you. You move on to certs. Okay, so solve the simultaneous equations. Wow, so challenging. Never see before simultaneous equation looking like this. Yes, correct.
Okay. Yeah.
On the left hand side, square root is 2y, 2y. Oh, sorry. Yes, you're correct. The denominator part. Yes. Yes.
And then
Yes. This implies. This one, square root means you have power half, so
3x
power.
plus y equals to 3.
Yes. Yes. Correct. Divide by 2. 3x plus y. Then 3x plus y equal to 3. Yep. Okay, you got it. Then after that, solve simultaneous. I won't bore you. You know how to solve.
Okay.
Don't need to go through. Can I skip? Okay, this is the trick. That's the only trick. Okay. That's it for exponents. The rest will be your homework for exponent for indices. You already know all this. I'm gonna move on to certs. Can?
Okay.
Should I go through this? Or do you want it as a challenge?
I don't know. I don't. Okay.
Got certs involved. Okay, I think I better go through. Sorry. This one it's really relevant to certs already. Certs is basically square root. Okay. It's fancy name for square root. Or cube root. Or any roots. But there are special tricks that we can do to deal with them. Okay, let's look at question 16. Find without using a calculator the value of n such that n times square root 5 equals to all this on the left. So n times square root 5 equals to 4, which is 2 square over 2 power half multiplied by 1 over square root 10. Here, do you realize that square root 10 is the same as square root 5 times 2, which is the same as 5 times 2 power. All right, so far. Then you can split it up, right? 5 power half times 2 power half.
Okay.
Which means that it's really just square root 5 times square root 2.
Yeah.
So certs, this is certs, easy or not? This is the first thing you must remember. Square root 10 can be split up into a product of its individual factors. So square root 5, square root 2. So another example would be like, I don't know, square root 15, split out as 5 is 3 times 5, right? So square root 3, square root 5.
Square root. Okay.
Right, multiply. Okay? That's the initial steps of certs. Then square root 10 over here is actually square root 2 times square root 5. I know that because I did the question before. Then 40 here, power half.
Square root 40. Square root 4, square root 10.
Okay, good. Then square root 4, square root 10. What's so special about square root 4?
2. So 2 times square root 10.
Good. Okay, let me just clean this up. Copy and paste it down. Yeah, this is just a 2. Okay, anything else? This part. Power half. What happens?
Square root 2 on the bottom.
Are you sure?
Wait, what? 2 to the power of 1.5 or 3.
1.5.
Yeah,
1.5. I'll leave it as 1.5. Okay.
Okay.
Anything special about 2 power 1.5? Okay, wait, no, sorry. Here you got brackets and plus, right? So what do you need to do?
Expand.
Distribute. Yes. Okay, so let's do that. So you got 2 power 1.5 divided by square root 2 square root 5 plus 2 power 1.5 times 2 times square root 10 over 5. Okay, good. Remember, we are trying to solve for m. Do you think it's time for us to divide by square root 5? Do you think it's a good idea? I think can. Okay. Also, I will split up the square root 10 here as square root 5 and square root 2 as well. Maybe I should have done that earlier. Okay, never mind. Not too late to do it now. Okay, so split it up as square root 5, square root 2. And then I will divide by square root 5 throughout. So what I mean is, hold on a second. Divide by square root 5 throughout, which means I introduce a square root 5. A square root 5. Does it make sense?
Okay.
Can simplifying, square root 5 times square root 5. Isn't that just a 5? Yeah, 5. So square root 2 times 5. But wait, 2 power 1.5 over square root 2. What's that?
Then that's just 2. So 2 over 5.
Yeah, it's just 2, right? Okay, it's just 2. Because just to explain, 1.5, then power square root is just power half, so 2 power 0.5. You can subtract the power. 1.5 minus 0.5 is just 1. Okay, Good. So yeah, it's just a 2 on top, then 5 at the bottom. That's 2/5 plus, let's take a look. Here you got 2 power 1.5, here you got square root 2. What's that?
That is 2 to the power of 2.
Which is?
4.
Then you times 2.
8
Okay, so
over
it's
5.
8. 8 over 5. What happens to the square root of 5? Cancel off. Exactly.
Cancel.
Then 2 over 5 plus 8 over 5, 10 over 5 equals to 2. M equals 2.
Okay.
You could have used a calculator for this. Oh, right? Correct or not? Just type this
Yeah.
whole thing in a calculator, then divide by square root of 5. But the purpose is without using calculator. Oh, okay.
Okay.
Okay. Time to move on to certs. Okay, this worksheet is done. 1.1 clear. The rest of 1.1 will be your homework. Okay. Let's move on to the next worksheet. 1.2. Okay. Indices substitution required. Maybe also quite easy for you. I should just select a few questions. Let me think. Should I do the advanced questions? Now I'll just do question 5 and question 6 from the basic ones. Those that I never go through will be your homework. Okay, so let me know if you have got any question you think I should go through. Okay, question 5, let's go. Using an appropriate substitution or otherwise solve each of the following. Let's look at part A. 5 power 2x minus 6 times 5 power x plus 5 equal to 0. This one make your own. Let y equals
to 5 to the power of x.
Okay, so what do you get?
So you get 25y.
No.
Wait.
Like this, right?
Oh yeah. Y squared minus 6y plus 5 equals 0.
Yes. So you realize that it's always a quadratic. It's the same trick every time. Confirm got a square going on. Must see this pattern. Bracket, then power 2. Okay, first term usually will be the one with the square. Okay, first term usually is the one with the square. Then calculator law, or just factorize it.
Yeah.
You get y equals to 1 or y equals 5. Yay, done already. Correct?
No.
No, you have to replace with 5 power x.
Yeah.
Oops. Right, 5 is just 5 power 1. So therefore x equals 0. Yes, correct. Sorry, I wasn't looking at the screen. Yes, correct. Okay, then part B. Just 2. 2 power 2x minus 10 times 2 power x plus 16 equals 0.
Let y equal to 2 to the power of x.
Okay. Oh, you said equal 2. I thought you said 2 already. Okay, don't know. Whatever. Never mind. 2 power x. Yes, continue. Very good. Yes. Factorize. What is it? I think it's y minus 8, y minus 2. Yeah. Then y equals to 2 or y equals to 8. This implies, are we done? No, we need to replace the y with 2 power x. So x equals?
X equals to 1.
This one, 2 power x equals 8. X
equals 3.
Power 3. 3. Okay, good. That is part B done. Let's move on. Question 6. Now they give you the substitution. Using the substitution u equals to 2 power x, you want to show, listen carefully, they said show. They didn't say solve it exactly. Okay, they want to show that the equation blah is satisfied by only one value of x. What does it mean?
I don't know.
Okay, this is a very weird way to phrase it. They're just telling you that solve this equation and then eventually show that there is only one correct solution. You probably will get a quadratic. You get 2 different solutions. One of them needs to be rejected. So only one left.
Because it's negative or what?
Yes, correct. Let's just do it. So 2 power 2x plus 1 equals 3 times 2 power x plus 2. 2 power 2x times 2 power 1. 2 power x bracket square times 2 power 1. Don't need power 1, it's just times 2. So what do you get?
What do you mean? What did I?
Solve. Use the substitution u equal 2 power x.
2u square.
Good.
Equals to 3u plus 2. Then
exactly.
move all one side.
Correct. 2u squared. Let me just move everything to the one side as well. Need to save some space. 2u square. Sorry. Wait. Let me get my eraser. 2u square minus 3u minus 2 equals 0. Calculator. Don't need to think. Just use calculator. 2u plus 1 u minus 2. Is it correct?
Yep.
Yeah, correct. Okay, so u equals to 2 or u equals
to minus
negative
half.
But u is actually 2 power x. So we replace. Remember
X
the goal
equals,
is to... Yeah.
And then this one, no solution.
Yes, it's a no solution.
Okay.
Correct. Yes, this is negative 2 power negative 1. No solution because of the extra minus. Y equal negative half is at the bottom here. Y equals 2 power x is at the top here. Okay, no intersection, no solution. Okay, good. Okay, the questions are all roughly the same. Do you still want to do more? Should I move on to the next one?
Anything.
Okay, I'll do a question 10. Question 10, let's go. Given that square root 8x times 4 power y equals 32 times square root 2, show that 3x plus 4y equals to 11. So square root 8x times 4 power y, it's roughly the same. It's just like the simultaneous equation question we had. Can you tell me what's so special about 8, 4, 32, and 2? Prime factorize, hint.
32 equals to 8 times 4.
That's true actually. Yeah, correct. But I think it would be easier if we prime factor. Yes, they are all powers of 2. Okay. 8 is 2 cubed. 4 is 2 square. 32 is
square. 32 is what? 32 is 2 power 5.
Yes, correct. Okay. Yes. Then that's what we're gonna do now. We're gonna substitute each of them with our prime factor form. So 8 power x is 2 power 3x. Then you take a square root. 4 power y is 2 power 2y. Because 4 is 2 square. 32 is 2 power 5. Square root 2 is 2 power half. Right? Can? And square root means power half, right? So it's 2 power 3x over 2 times 2 power 2y equals 2 power 5 plus half. So what can you conclude? Again, same base, different power, multiply, add the power. Same base 2, but you add the power. This part okay, right? Adding the power. Can good. Then this one 5 plus half. 5.5. I'll just write 5.5. Then therefore you can conclude 2 power something, 2 power something. Therefore the powers are the same. What can you do? Times 2 times 2. Okay. And you simplify, you get 3x plus 4y equals to 11. Should. Can?
Okay.
That's 10 part 1. Let's move on. 10 part 2. Given that 3y over 9 power x squared equals to 1/3 times 3 power x, show that y equals to 2x squared plus x minus 1. Wait, let me write down first. Okay. Anything common about the bases? 3, 9.
3. So 9 equals to 3 to the power of 2.
Okay, so therefore 9x squared is actually just 3 square power x squared. So what do you do with the powers 2 and x squared? Plus, minus, times, divide?
Times.
Square only. So that means that the denominator becomes 3 power 2x squared. 3 power y on top. Equals to 1 over 3 is 3 power negative 1. 3 power x is still power x. Correct or not? 1 over 3 is 3 power negative 1, right?
Uh-huh.
Good. So same base 3, different power. What do you do with the power? Multiply or add?
Add.
So is it negative x or is it minus 1 plus x?
Minus 1 plus x.
Very good. Please be careful. Minus 1 plus x. Okay, then the left-hand side, same base, different power, divide.
Y minus 2x squared
Equals to 3 power minus 1 plus x. Same base 3 on both sides of equation, different power. They are not different. They are actually equal. Equate the power. Yeah, rearrange and then you get the y equals 2x squared plus x minus 1. So now part 3, hence solve for x and y the simultaneous equations. Wow, so difficult, never see before. What is that?
It's just, wait, what's the just now one?
Sorry?
What's the just now?
What do you mean just now?
Oh yeah.
Yeah. It's all here. And
oh yeah.
Solve. How? Wow. Sub here, sub there. Wow, very difficult.
This and this.
Exactly. Yes, correct. You just need to use the resultant forms and then you solve them. Okay, maybe I'll label, call this equation 3, call this equation 4. 1 is equivalent to 2. Oh, sorry, 3. 2 is equivalent to 4. So solving, so that means we solve 3 and 4 instead, simultaneously. Okay, simultaneously. So let's take a look. What we have, y equals 2x squared plus x minus 1, 3x plus 4y equals 11. What can we do? Substitute, right? Maybe I can say sub 4 into 3. What do we get? We get 3x plus 4y equals 11. What's y?
Y is 2x squared plus x minus 1.
Yes, exactly. Then you can just solve. Okay, let's go on. 3, let's just quickly solve this. 4 times 2, 8x squared. 4 times 1, 4x. 4 times negative 1 minus 4 equals 11. 8x squared. 4 plus 3, 7x. Minus 4, bring the 11 over, minus 11, minus 15. Can?
Yeah. X equals to 1 or x equals to negative 15 over 8.
Yes, perfect. Very good. That's it. Wait a minute. Let me think a little bit. Okay, can, nothing wrong. Sometimes especially when there are square roots, involved, you have to be careful, okay? Because whenever you get negative answers, there's a chance that you might introduce imaginary numbers. You square root of a negative 4, for example. This is impossible. Not at your level, not at Amex. You do not need to know how to solve this. If you encounter this, then it means you need to reject one of the answers. But in this case, we are safe.
Okay.
Like the only case we have a square root is square root 8 power x. Square root 8 power negative 15 over 8. I believe you can still calculate this. I'm not going to try and calculate this. Okay? Can. Good. That's question 10. Should I do anything else? Advanced. I want to do advanced. Or should I go on to certs? Yeah, I should go on to certs already. I'll leave this to you. The rest will be your homework. Do you want me to go through any of the advanced questions? No, it'll be your homework already.
Okay.
Can? Okay,
yeah.
can.
Wait, then this is what? What is this?
What is this? What do you mean? Oh, wait, there's also additional homework. So this is 1.2. This is 1.2. In addition to 1.1 and the 1.2 questions I haven't go through, I will also assigning you homework 1. A lot of questions. Sure, don't need to go through.
No, it's okay.
Can yeah, I think they are not that bad. Okay, moving on. New topic. Okay, 1.1 clear, 1.2 clear. What's the next one? Number 2. Not homework 2, sorry. Let me find the correct file first. Search supplementary. Let's go. Okay, I'll use the one with the answer. Wait, should I use the one with the answer key? Yeah, just use the one with the answer key. Why not? Okay, this is certs. Certs, how do you deal with it? First thing is basically just power half. Square root of a is just a power half. Then some of the tricks you need to know is square root a times b is just square root a times square root b. And another trick you should know is called rationalizing denominator. This is a new topic. Rationalize denominator. So in rationalizing the denominator, here's what you do. So whenever we got, like, for example, square root of 4, it becomes a 2. This is what we call a whole number, no decimals. And 4 is what we call a perfect square. Sorry, maybe I shouldn't. 4 is a perfect square. What are examples of perfect square? 1 square, 2 square, 3 square, 4 square, so on. Okay, when you square root these numbers, you get a whole number. They are called perfect squares. However, there are sometimes you get square root 5. Is this a perfect square? Is 5 a perfect square?
No.
No, because after you take the square root, you get decimals. What is square root 5? 1.7. No, that's one square root 3. 2.236. ... Okay, so this is because there are decimals. You cannot actually express it as a fraction, like we are at least not a finite fraction. You can have continuous fractions, but that's another topic for another day. This cannot be expressed as a fraction, a over b, where a and b are whole numbers, or in actually more specifically, this one integers, that one is natural numbers. If you cannot rewrite it as a fraction, it means it is what we call a irrational function. Double R. Irrational number. Rational numbers are numbers that can be written in the form of a fraction. So for example, 7. 7 can rewrite as 7 over 1, or 14 over 2, or I don't know, 21 over 3, blah, 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 which means that it is rational. You can rewrite it as a fraction. Those that cannot be written as a fraction, they are irrational, such as square root 5. Is that clear?
Okay.
Okay, that is irrational number. Square root 5 is irrational. I should write down a sentence. Square root 5 is irrational. And the problem with irrational number is that, let's say we want to calculate what is 1 over square root 2. Like maybe doing Pythagoras theorem or something, somehow encounter this. How do you calculate it before the world of calculators? You will need to look up a table of values. Then square root of 2 can be looked up at a table of values to be 1.414 ... Okay, from a table of values. Then you get 1 over 1.414 after you look up a table. There's a table of square roots. Last time, before calculators, they had calculators last time was super huge, and people had to manually calculate the number one by one. And since it's very slow, they write it down on a piece of paper, a book, and then they publish the book of values, table of square root values. Then one of them is square root 2, which is 1.414. Then how do you calculate 1 over 1.414? You need to do long division, if you remember from primary school. This is actually, if you approximate it, it's 10,000 over 1414. Right? 1, 2, 3, 1, 2, 3, oops, extra 0. Then you have to do 1,000 over 1414. How do you do that? You have to memorize the 1414 times table. Then you must add on a few more zeros. 1.000, then just keep on dividing. Long division. Remember primary school?
Honestly, no, but okay.
Okay, you don't remember long division? Okay, never mind. So the basic idea here is it's very long-winded, it's very slow. This is too difficult. So that's why in the world before calculators, you have to introduce, this idea is important. It's called rationalizing the denominator. Denominator, I hope you know what's a denominator. Fraction got a top and bottom, denominator is the bottom part. Okay. So 1 over square root of 2 is actually just the same as 1 over square root 2, but you multiply top and bottom by square root 2. Agree?
Okay.
Yes? Then square root of 2 is actually just square root of 2 on top. Then square root 2 times square root 2 is what?
2.
Sorry, there's a 2, yes. But if we look up on a table of values and we found out that square root 2 is 1.414 approximately, then we just divide by 2. I think you don't need to do long division for this, right? You can even do it in your head. 1,414. 1,014 divided by 2 is
0.707.
707. Right? Wow, so fast. You see, compared to just now, horrible. 1,000 divided by 1,414. So difficult. So in the world before calculators, this was very valuable. Rationalizing the denominator helps ancient people to calculate the value, approximate the value of 1 over square root 2, for example. Does it make sense?
Mm-hmm.
Okay, so now honestly, rationalizing the denominator is just in the syllabus to test students' IQ for testing purposes. There's not much real world value to it anymore with the invention of a calculator.
Wow.
Yeah lah. So most of the syllabus is outdated. You have a calculator, why would you need this? I don't believe that the world will suddenly not have calculators. So this is not very relevant to real life anymore. It's just a fun little game, to be honest. Yeah. So let's just do this fun little game. It's part of the syllabus. So let's just learn that. Yeah, before you use the technology, you should learn to understand what's going on behind it. Okay, so let's just go through the questions one by one. Oh, right. I should go through some basic questions before I go through the question one. So basic examples of rationalizing denominator. So let's say you got 1 over square root 5. Rationalize the denominator. What would you do? Multiply top and bottom by?
By square root 5 or square root 5.
So what happens to the denominator?
Become 5.
So we have rationalized the denominator. No more what we call surds. Okay, surds are the square root a, square root something. Okay. Okay, good. Another example. This is 1. This is 2. Now I'm gonna upgrade. Square root 3 plus square root 2. Oh no. How can you get rid of square roots and make sure that it's a whole number at the bottom?
Okay. Times what? 3 minus.
Very good.
Is it?
Correct. Yes. But you must make sure you only multiply by 1. You don't want to change the value. So that means you just have to. How did you know about this?
Is it cause like this thing? No.
Correct. Yes, it is because of that thing. A square minus b. Let's write it down. A square minus b square is equal to a plus b times a minus b. So here it's a, there is b, there is a, there is b. A plus b times a minus b. You're left with, at the denominator, a square minus b square. Then numerator, 1 times square root 3 minus 2 is just square root 3 minus 2 minus square root 2. So the numerator is irrational. Okay. It can be proven that irrational number minus irrational number is still irrational. I will not bother proving it here. It's something called a proof by contradiction. You can go look it up yourself. I'll write it down for you. Maybe you should look up square root 2 is irrational. Wow, I tell you, your mind will be, if you like this, then you should seriously consider studying math. You go and look it up. Square root 2 is irrational proof. Okay? It will help you. If you like it, then you should consider studying math. If you really hate it and you find it extremely confusing, avoid math at all costs. Avoid math at all costs. Yeah, at university level. Okay, then square the square root 3 and then you get a 3. Okay? Oops. Pen. 3 minus square root so square of square root 2, then you get a 2. Then you get root 3 minus root 2 over 3 minus 2 is 1. What a coincidence is a 1 dividing by 1 gives me just the numerator. Ta-ding. Can?
Okay.
Okay, another basic example. Let's try the next one. 1 over, I don't know what number you want. Give me other numbers.
Oh, I don't know.
7, 5, 4. Okay, don't want 4. This one, actually can. I should give a whole number. Actually, I put a 2. Then how? Whole number plus irrational number is still irrational. So the denominator still need to multiply by what? A
Wait,
plus B,
A
then
minus B.
A minus B. So it's square root 5 minus 2. Correct or not? Top and bottom.
Okay.
Okay. What happens to the denominator? A plus B times A minus B.
A square.
A square minus
Right.
B square. Numerator just square root 7 times square root 5 minus 2. Okay. Simplify, square root 35 minus away square root 7 times 2, 14. Over. What happens to the denominator?
5 minus 4, 1.
What a coincidence, it's a 1. Then divide by 1 means we can just leave the numerator alone. That's our answer.
Okay.
Okay, let's try another example. Square root 2 over, let me think a bit. Make it ugly. Okay, square root 7 over square root 5. Hey, why I give you plus all the time? I give you minus now. How? Oh no, there's a minus.
10 times by plus, no?
Exactly, correct. Yes, nothing difficult, right? Just multiply that by the plus version. So square root 7 plus square root 5. Top and bottom, remember? Top and bottom as, not just the bottom, top as well. So multiply out, what do I get? Square root 2 times square root 7, square root 2 times square root 5. You get square root 14 plus square root 10. Divide by, can you tell me what's the bottom?
7 minus 5.
Exactly. So it's divide by 2. Okay. Then this one, square root 14 plus square root 10 over 2. You can rewrite it
can
as
bring out 2. Yeah. Yeah.
sort of like this. Or if you want, you can also write it like this, half times, which is the same as half times plus half times this. Okay, half times square root 14 plus half times square root 10. Equivalent.
Okay.
Is that okay?
Yeah.
Good. Okay, I think that's honestly quite a lot of examples already. Next example I want to give you. Let's say that we want to they will usually have this kind of question, like square root 3 over square root, let me calculate in my head first. Okay, and then I want let me think a bit. We give a 13. I'll put a 12. Okay. They will want you to they will say that rewrite this in the form of A plus B times the square root of C. Or maybe I should put a whole number here. 2. Okay. They will expect you to rewrite your answer in this format and solve for A, B, and C, where A, B, C are integers.
Yeah.
Positive, sorry. How would you do it?
I'll do the same, like yeah.
It's called rationalizing the denominator. Yeah, rationalize the denominator. So what do you multiply?
Times square root 13 plus 12.
Top and bottom, right?
Yeah.
Okay, not just the bottom, not just denominator.
13. Wait. Yeah. 13, then minus 12 square. 144.
Oh. Okay, yes, correct. Yes, good. I just hit my hand against the table. Nothing. Okay, so yeah, then 2 you multiply, so you get 2 square root 13 plus 24. Okay, 2 square root 13 you can't do much. I think it's quite simple already. Of course, if you want, you can rewrite as square root 2 square, which is square root 4. Then both got square root, then you can combine. 4 times 13, 52. I think 2 root 13 is fine. Okay, simplify 13 minus 144. What do you get? It's right over here.
Minus
Negative.
131.
Okay, then 2 root 13 plus 24. Okay, then you can split it up into, oh, sorry,
A
never mind. It
equal-
shouldn't be integers, be rational numbers. Yes, sorry. Yes, correct. Okay.
Wait,
I'll
what
just
is-
copy down your answer. 24 over negative 131. And then B is, in this case, it's a 2 over, oh, handwriting very bad. Let me try A plus B root C. So A is on its own 24 over negative 131. B is the coefficient, so 2 over negative 131. C is 13. Can? Okay, These are basic examples. Now you're ready for the question. Let's go. Cut. 353. Oh. Wow. Okay, given that s is equal to 3 minus square root 5, you want to express x squared minus 2 over s plus 2 in the form of a plus b square root 5, where a and b are rational numbers. Okay, how would you do that? You just have to substitute in. So I think it would be nice if we just calculate the pieces in the numerator and denominator separately. Then we bring them together. If not, it's going to be very messy. So what is s squared? It's just 3 minus square root 5 squared. How would you do it? I hope you remember a minus b bracket square. So what would it be? 3 square 9 minus 2 times 3 times root 5 is 6 root 5 plus root 5 square is a, what is it?
Root 5 square is 5.
5. Okay, very good. So 9 plus 5 is 14 minus 6 root 5. Okay. Maybe if you want, you can factor out a 2. So 7 minus 3 root 5. What else? We got s plus 2. Let's see what's that. 5 minus root 5. Correct?
Yeah.
Can Okay, good. Actually, this factorizing out the 2, yeah, I think it's useful. Just factor out the 2. Then let's figure out what is s squared minus 2 over s plus 2 now. Just substitute in s squared minus 2. Wait, maybe I should also calculate that first, just to be a bit neater. S squared minus 2 is actually what? 12 minus 6 root 5. Which, actually I shouldn't bother factorizing here, because I need to minus 2. Then I can factor out a 6 now. So it becomes 2 minus root 5. Then you sub in 6 multiplied by 2 minus root 5 divided by 5 minus root 5. Is this part okay so far?
Okay.
Can now? Yeah, so good. That means we'll continue. 6, you leave it alone. But you actually got 2 minus root 5 over 5 minus root 5. Correct?
Yeah.
Okay, then how do I continue?
Times the 5 plus square root 5.
Bottom only?
And both cos equal 1.
Yes, correct. Oh, by the way, they are called conjugate surds.
Okay. Conjugate.
Yeah, you heard of it?
No.
Conjugate, yes.
No, now, okay. Yeah, okay. I'll say that next time.
Doesn't matter. It's just tell me what it actually is. 5 minus root 5, 5 plus root 5. Okay. Minus become plus, plus become minus. Okay. So 6 times you leave it alone, but you focus on the 2 fractions here. That's why we had to, this is the advantage of factorizing out the 6. You don't have to deal with such big numbers. If otherwise you would be dealing with 12 and 6. You need to square those numbers, which is quite painful. Okay. I'll show you another example. Okay, wait, I need to write this down. Show example of what is 2 plus 3 root 5 1 over. Okay, try and rationalize this one. Okay, to go through later. Okay, carry on. So now denominator, a minus b, a plus b, a square minus b square. A square, 5 square, 25. Square root 5 square, 5. So minus away 5. That's a 20. Then numerator, no choice, multiply. 2 times 5. 2 times root 5. Negative root 5 times 5. Negative root 5 times positive root 5. Minus times positive gives you negative. Root 5 times root 5 gives you? What does it give you?
5.
5. Very good. So 6 leave alone. Actually, can simplify already. 6 over 20 is what? 3 over 10, right? Then you're left with bracket whatever was on top. Then 10 minus 5 is a 5. 2 root 5 minus 5 root 5 means 2 minus 5 is negative 3. Negative 3 root 5. Is that okay?
Okay.
Okay. And then you can actually bring back the 3 over 10. 3 times 5, 15. Oh, wait, actually, yeah, just 15 over 10. Then minus away 3 times 3 is 9 over 10 root 5. 15 over 5 can be simplified as 3 over 2. Huh? I think so. Yes.
Okay.
Then what's your final answer? Read the question. They said, in the form of a plus b root 5, where a and b are rational numbers. Does it answer the question? Yeah, it's the same as answer. So yes. Okay. Okay, now go through this example. 1 over 2 plus 3 root 5. Okay, let's see. So how do we simplify this? Top and bottom
Times
multiply by?
conjugate.
Correct. What is the conjugate?
2 minus 3 square root 5.
Yes, exactly. Okay, so let's check what happens. This is more complicated because there's an extra number in front of the square root. What do you get for the denominator? A plus b.
4 minus 4. Wait. Is it what is it? Is 45? No. Yeah.
Yes. Okay. And 2 minus 3 root 5. 4 minus 45, negative 41. Then you can split as 2 over negative 41. And minus become a plus 3 over 41 square root 5. Can?
Yeah.
Okay. Yep. So just a reminder on the plus become minus thing. Okay, next example. Okay, what time is it? It's 4 p.m. The rest of the questions are pretty similar. Okay, the ones that are a little bit challenging would be when they give you a power 4, so you need to use binomial expansion.
What the?
Is that a good idea? Probably not. Probably not. Because you probably should rationalize it by a power 4 this time.
What the? Okay.
Because both got power 4, you can just multiply the insides. Right? And it simplifies into what? I'll leave you to think about it. What do you get after you multiply them? It should be quite simplified. Okay, then other ones would require you to remember the area of a triangle and stuff. Finding the length of AC, right? Given two lengths. What is there? What kind of rule do you need to use?
Oh my god.
What's that?
Yeah.
Remember cosine rule? Remember cosine rule? That would be the case if this is any other angle, but here is a very special angle, 90 degrees. So you don't need
Pythagoras.
Pythagoras can already. Don't need.
Nice. Okay, good.
Did you know that cosine rule is just a general version of Pythagoras theorem, where the angle is not just 90? It still works. Cosine rule still works when it's 90 degrees. It simplifies into Pythagoras theorem.
That
You
makes
just
sense.
go look at the formula, cosine 90 degrees. You just get if I'm not wrong, it's a 1. Yeah. Hold on. No. Cosine 90 is 0. Yeah. And it simplifies into Pythagoras theorem. Okay, then the rest are all kind of similar. Maybe I shouldn't assign homework 1. It's a lot of questions already. Let's see. Oh, just take note. Here you got. It's good to not treat this as separate things. Like don't treat it as a plus b and then you go and multiply 1, 2, 3, 4. No, you should group this together as one thing, then multiply by the 1, multiply by the second guy.
Okay.
Can maybe I box it up in case you forget. Let me see other hints for you. Area of a rectangle, they give you. Length, they give you. Then you want to find the width. So of course, you have to find the width, you just have to divide, right? Area divided by length give you width. So this divide by that. Can? Mic test can hear?
Yeah.
Can Okay, then question 15. Okay, maybe I'll ask you to skip this for now. I'll go through in class. Go through next week. I'll go through this next week. It's quite difficult. Yeah, it's quite difficult. Yeah, I'll go through next week. This one you can handle. Yeah. But a good idea would be to simplify, like for example, square root 27 is what? It's square root 9 times 3. So it's like square root 9 times square root 3, which is 3 root 3. It will be easier to simplify as 3 root 3 first. And other similar things, square root 12. You can also simplify. I'll just tell you it's 4 times 3 first. Square root 4 times square root 3, which is 2 root 3. Try to take out as much as you can, perfect squares. You just need to prime factorize it and you can easily rewrite it in this format. Can?
Okay.
Can. Any other things? Okay, this one question 13 also skip. Yeah, okay, homework 1 I'm gonna not assign you. This is a lot of questions already. This I paper. Area of rectangle, they gave you. Length, they also gave you. Then you want to find the breadth. Oh. Let me ask you, if you got 1 over 2 root 3 plus 5 root 7, how do you rationalize this? Times what? The conjugate, right? What's the conjugate?
2 square root 3 minus 5 square root 7.
Top and bottom, right? Okay, good. You get 2 root 3 square minus 5 root 7 square. Is this clear?
Okay.
A square minus b square is a plus b times a minus b. Then you simplify, so on and so forth. Okay, that's the clue. That's the clue here. This is CLUE. Not relevant to the question, just not exactly relevant. But this part here, you need to rationalize. Yeah, after you divide area by length. Okay, this one simplify. I'll leave that to you. Solve the equation. I'll ask you to skip. Those I never ask you to skip means you have to skip. This one also skip. This one also skip. I mean, you can try it if you want to. Yeah, this one can do. This one skip. This one you can try, a little bit challenging. This one you can skip. Can? Okay, then that's all for today. I will type a message to tell you what are the questions to do. Can?
Okay, nice. Yeah.
Okay. Can. That's all. Bye-bye.
Okay, thank you.
Thank you. Bye-bye.